Okay, so if we want to solve this equation, which is very similar to this one, there are solutions. Reason being that this row is a multiple of this row, right? Now, if you have a 2 by 2 matrix, it's very easy to see if a row is a multiple of the other, right? And you don't really need to go to the determinant. You know that if one row is a multiple of the other, the determinant will be 0. You can kind of work out symbolically why that's true. And you can always do the determinant because it's a 2 by 2. It's easy. Okay? Well, I could say the determinant so solutions exist. Matrix is not invertible. Now, if you have a 3 by 3 matrix, it won't be as clear. So you do the determinant and find that it's 0. Well, that again tells you there are going to be solutions. Any size matrix, okay? So, determinant 0, so solutions exist. This, because the matrix is not invertible, you can't write this, which would, if you could, ensure that the solution is 0, okay? So what we do is, we write out 2x plus 3y equals 0, and negative 4x minus 6y equals 0, okay? Or we write out the augmented matrix, which reduces to what? If we're going to reduce this matrix, first thing we're going to get is a row that says 1, 3, half, 0, right?
Yeah.
And the second row is going to be what? Zero, 0, 0, right? So x plus 3 halves y equals 0. Y equals negative 2/3 x. So your solutions are multiples of any column x, y, where y is negative 2/3 of x, right? Well, I'm going to say let's let x equal 3, then y is going to be negative 2. That's one solution here. And any multiple of this is going to be another. Okay? Meaning that the set of vectors that map onto the 0 vector in this case, I'll give you a little terminology, you don't have to know it now. We have y equals negative 2/3 x. Okay? Any vector along this line is going to map to 0. Okay? Any vector along this line maps to 0, meaning that we're collapsing two-dimensional space when we multiply it by this matrix, giving us a line over there. Okay? And we can determine what that line is. Now that comes later. But the whole idea that when the determinant is 0, you're collapsing the space that you're mapping. And that's something that you can kind of intuitively understand. Okay? And it'll be handy if you understand it now, because then later when you see it, you say, oh yeah, well naturally. Okay? Then you don't stumble over the idea later. So I mentioned it now. But right now, main task is just understanding what it means for the determinant to be 0 in terms of this equation. Okay? Very important equation because, again, tells us about the structure of this transformation. Okay?